Today we're going to be covering another Amazon's interview question. This is Leetcode question number 31, next permutation. What they're saying is like if you have a permutation, tell us or give us or return the next permutation. So in the case of 1, 2, 3, the sequence of permutation goes like this: 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1, and back to 1, 2, 3. Couple of things you need to know is like, one is that the total number of permutations, if we have n number of elements, we can have n factorial permutations. So a trivial solution is, there is another solution on question on the Leetcode where you can actually come up with all number of permutations. So that actually is gonna give you n permutations. So there are multiple ways, like you can recursively get to those n factorial permutations, or you can use a queue in order to get to it. But once you get to those permutations, you're just gonna be looking, either save all of them or like either save all of them or and then compare it what's going to be the next permutation. But that would be the trivial solution here. The algorithm we're going to be using is going to bring the time complexity to O of n and space complexity to no extra space, that would be O of 1. And it is not that trivial solution, and the thing is you need to know how to do it beforehand. Otherwise it's really hard to come up with this solution in 30 minutes. So 1, 2, 3. So let's take this example of, which one is it? Let's take the example of the second one, which is 1, 3, 2. And we need to come up with 2, 1, and then 3. So when you have this input as 1, 3, 2, the algorithm goes like this. You can do is like, from the right hand side, keep going back until you see a smaller number. So ideally the last permutation would be 3, 2, 1, right? And if you are going back, you will end up in a situation where you won't find any scenario, any case where a number where you are at, the next number going to the from the right to the left, is actually smaller than the previous number. That so in the end you will actually end up coming even like the -1 index, and you won't find any instance where uh, uh, where you actually were able to find a number which was less than the previous number. That being said, in that case the answer is just reversing the whole thing, right? So we can reverse the whole thing and that would be it. But let's talk about the scenario where we can find something. So currently the current element is 2. I will say the next element is 3. So you came here, you saw that it is 3 now, right? And it is still not less than the previous element, right? So you're gonna keep moving until you find something like that, right? So now in this case, when you are here, the current element, actually one can be I, one can be I negative, right? So basically when you are here, the I minus 1, initially we started with I as 2. At that case I minus 1 was 3. Then we came here, I became equal, sorry, then we came here, I become equal to 3, I minus 1 became equal to 1. So in this case, that I minus 1 over here is smaller than I, So what we wanna do is we wanna remember where which one is our I minus one. In this case, oh my goodness. In this case, I minus one is at index. This is the value, right? These are the values of that. So if you think, if one thing you want to know is that we want to save that I minus 1, that is this location, and that is going to be 0th location. That being said, we want to go one more time from here, right? What we need to do is, uh, let's just copy that again. We said this is I, this is I minus 1. We saved everything, but we want to go one more time and starting with the J, and we want to say that which element, again, which element is, so basically while the element at the jth index is less than or equal to this number, we want to keep moving our j. But in this case, the thing is that the j is already greater than, even when we started from the rightmost side, the j was already greater than the I minus 1th index. So I minus 1 index value. So 2 is greater than that, so we want to stop our j right there, and we want to swap this j with the I minus 1. So once you swap it, it's gonna become equal to 2, 3, and 1. And then we're gonna leave this element, and the rest of it we wanna reverse. So it would be 2, 1, 3. That would be the next permutation. Let's get to the steps one more time. Our I, we are starting, in this case, we are basically, instead of doing these things, another way of doing it is consider that our I is here, we started from here, and the other thing we want to compare it is with the I plus 1. So it's just the index thingy. So we'll start with here, from here, and we'll compare it, this I with I plus 1. So everything is gonna stay the same. The thing which we wanna remember is I this time, which is the 0th index, and we wanna remember that. And then in that case, if you take that example where we are comparing I plus, when you have that, the next time you want to do is the j starting from here, and we want to swap that. So that's what they are talking about. Why didn't I bring it here? So that's what they are saying, that start the I with the nums dot length minus 2. We did that. Our initial I was here. Oops. Our initial I was here, right? While the I is still greater than equal to 0 and nums of I plus 1 is less than equal to nums of I. As long as this and I plus 1, as long as this number, like this number, the one after I is less than equal to this I, keep going to the left. That's what they are saying. We're gonna keep doing that until we see a number less than, like I plus 1 is basically becomes greater than the ith element. In that case, we're gonna stop our I, and the next step, as I said, if we were able to find that I greater than equal to 0, then we need to swap it, otherwise just reverse it. So in this case where uh, we had, I don't even have it, in the case of this one, 3 2 1, when you do that, you're gonna end up, our I is gonna stop, I is gonna stop equals to -1. So I is gonna stop right here, and we're gonna become, it's not gonna, it won't be able to see any instance where the ith index is actually less than the I plus 1. So in that case, we just need to reverse the whole thing. Reverse basically the nums and the I plus 1, meaning start the reversing from here all the way to the end. And if it is anywhere in between that, you need to swap. You need to go one more time from the left to the right until you see, uh, that the nums of j is less than equal to nums of I. Then you're gonna say, j, keep bringing the second pointer to the left until you see then basically a number which is actually bigger than the jth element, any jth element which is actually bigger than the ith element. Then you're gonna stop here and then swap the I and the j. Swapping is simple, and reversing is also, we already know the total length of it, so you are basically swapping it. uh, yeah, that is very basic. Reversing the elements is gonna be, you have one pointer, it's a two pointer reverse, one pointer at the beginning, one pointer at the end, and keep reversing until the I is less than j. Keep swapping them. So, and keep incrementing the I, keep decrementing j. That's all I wanted to cover in this video. Thanks for watching.